Hey, everybody. We are going to get started pretty soon here. Let me get set up with my other channels. I'm trying Restream for the first time today. I gave it a little bit of a test run earlier today, but let me make sure that I'm set up on my other channels and everything. Trying to stream on Facebook and on YouTube and on Instagram. So give me just a second here. We'll get started. Okay. Got Facebook. Instagram's a little different. Okay. I don't know if I'm going to keep this or not. Okay, looks like we're good on Instagram. And then last but not least, let's go to YouTube. Okay, we're good there. All right, thanks guys. Thanks for hanging out with me. Facebook, Instagram. All right, great. I'm going to try to keep up with the chat in each of these locations, so bear with me on that. If you would like to say hi, please do so. I would love to hear from you, see who is here, especially since I am streaming on all of these different platforms. So I'm hoping that gives me a little bit of a wider audience. I've been doing these live streams this time on Thursday for a few weeks now. And my goal really is to just give some extra help to students out there, parents who might need a little bit of extra help with helping their kids. This time is usually homework time for a lot of people. So I'm hoping that this will be helpful for everybody. So we're going to, these are the topics we're going to cover today. I'm going to spend about 20 minutes on each pre-algebra and then algebra 1. For pre-algebra, we're going over the Pythagorean theorem and the triangle angle sum theorem. And then in algebra 1, it seems like a lot, but they're all kind of connected to each other. We're going to go over how to square binomials and multiply conjugates. So that's just multiplying the two different binomials together. And then we're going to undo that multiplication by factoring each one. So the square binomials will create a perfect square trinomial. And then the conjugates will create a difference of two squares. And so then we're going to factor that. So we'll get into all of that soon too. Again, let me know if you're here. I would love for you to say hi. If you're not already subscribed on YouTube or following me on whatever platform you're watching on, then that would be great if you could do so. Also, feel free to ask questions. If you have a specific homework problem that you are struggling with, then we can totally switch gears and I might be able to help as long as you have a way to ask the question, or, I can always try to like give you an example of something if there's like a particular skill that you're not sure about how to do. So let's go ahead and get started. Let me see. Let me make sure I've got all of my comments pulled up over here just in case that comes up. I don't know if you can hear that, but my printer is doing its automatic update right now. So of course that's the time that it picks to do that. All right, let's go ahead and get into our pre-algebra. We're going to be talking about Pythagorean theorem. All of these worksheets are on kudasoftware.com. If you would like to go there, they have free worksheets that you can download. You don't even have to download them. You can just open them there on the site and print them out if you would like to go through some of these problems with me. These are from the pre-algebra section of Kuda software. So there's like a little drop-down menu where you can find and it'll say Pythagorean theorem on there. So let's go ahead and get started. So Pythagorean theorem is, let me give you the formula. We'll start with that. Is a squared plus b squared equals c squared. So what does that mean? A and B are both what we call the legs of the triangle. So these are the two sides of the triangle that create the 90-degree angle. Pythagorean theorem you can use with right triangles. You can either, in this first section, we are going to determine if these are right triangles or not. If we can plug in the side lengths into the Pythagorean theorem and it works out to be a true equation, then these are going to be true right triangles. If it doesn't work out to be a true equal equation, then they're not going to be right triangles. So A and B are the legs of the triangles. So looking at these two triangles, it looks like this would be probably the right angle if it is truly a right triangle. And this angle would be the right angle if it is truly a right triangle. And so then that means that these two sides that create this right angle, those are going to be our legs of the triangle and are going to be and are going to create that right triangle. Those are going to be the A and B sides. Now, it doesn't matter which one is A and which one is B. Because we're adding them both together, we can add in any order, so that's why it doesn't matter if it's A or B. C, however, is always going to be the hypotenuse. It's going to be the side that is across from or opposite from the right angle, or what should be the right angle if these are true right triangles. So the C is always on the other side of the equal sign from the a squared and b squared. That's something that is one of the more common mistakes that students make. So let's go ahead and plug our A's, B's, and C's in and see if these are true right triangles. I'm going to just erase all of this stuff just so it's not in the way. So I'm going to go ahead and call this side A. The 6 is going to be A, the 8 is going to be B, and the 9 is going to be C. So let's substitute it in. A squared plus B squared equals C squared. Okay, awesome. So a squared is going to be 6 squared, and we do always have to square these numbers. We can't just plug in 6 plus 8 equals 9. That is not how we test right triangles. We always have to square each of the A's, B's, and C's. And we can get, maybe if there's time, we can get into that a little bit later of why and how that works. All right, so 6 squared is 36, 8 squared is 64, and 9 squared is 81. So we're testing, does 36 plus 64 equal 81? So 36 plus 64, 6 and 6 is 10. So we would regroup to the tens place. 3 and 6 is 9, plus that extra 1, so that's 100. So this does not work out to be a right triangle because this equation is not true. So this is not a right triangle. Okay. It is a triangle. Obviously, like we have the length of these sides. It is just not a right triangle. Let's test this one. Again, we'll make this one A. Actually, let me just mix it up just so that you can see that it doesn't really matter which one is A and which one is B. I'm going to make 5B and 12A, and then 13 has to be C. I can tell that these angles are not going to be the right angles, and the longest side of the triangle is always going to be your hypotenuse, is always going to be that C side. So that's how I know that 13 is C and not 5 or 12. So let's plug it in. So we've got 12 squared plus 5 squared equals 13 squared. So 12 squared is 144. 5 squared is 25. 13 squared is 169. And I always tell my students, usually students will have to memorize up through their 12's multiplication facts. But then once we get to this part, we're multiplying, we're squaring 13, 14, 15 a lot. So you'll start to see these squares and you'll start to memorize them just as much as you know, like 12 times 12 and 11 times 11 and all of that. Anyways, okay, so then let's add this up. 5 plus 4 is 9, 2 plus 4 is 6, and then we've got that 100. So this does turn out to be a true equation. So this is a right triangle. Okay, great. All right, so then let's go down. Now we're going to find the missing side length for these right triangles. So we are being told that these are right triangles. We can see that little box there in the one angle of the triangle here, but we don't see a measurement here. So that's what we're trying to find. So because these two sides create that 90-degree angle, then we know that these are the A and B sides. These are the legs of the right triangle. So again, A squared plus B squared equals C squared. And again, it doesn't matter. You can make 5A or you can make 5B. I'm just going to go ahead and put 2 squared plus 5 squared. So this is going to be my A and this is going to be my B. And we are looking for C. So we don't know what C is, so I'm just going to leave it as C squared for my equation here. And then we're going to use algebra to solve for C. So we do need to square each of these first. So 2 squared is 4, 5 squared is 25, and that equals C squared. And then we've got 4 plus 25 is 29 equals C squared. And then this is the part where I would say most students make a mistake here. They'll say, oh, okay, I got here, so C equals 29. But that is what C squared is. C is just one linear measurement of this side of the triangle. C squared represents, if we drew a square out from the side of this triangle, it would be whatever C is times C again. It would be the area of this big square here, right? Because for the area of a square, you would take the side times side. Or if you want to think of it as length times width, then that's another way to think of it. So this is where a lot of students that I work with run into some mistakes here. We have to remember to take the square root of both sides of the triangle. So 29 is not a perfect square. Sorry, I wish I would have chosen a problem that was a perfect square, but maybe some of these other ones will be. 29 is not a perfect square. I don't think we can simplify that at all. So the measurement of C is the square root of 29. So we get C equals the square root of 29. All right, let's try another one over here with number 14. Again, it looks like we've got the legs of the right triangle. So that's going to be our A and B. So we'll do 3 squared plus 10 squared equals C squared again. Again, we're looking for C, so we don't know what that one is yet, so we're just going to leave that as C squared. So 3 squared is 9 plus 10 squared is 100 equals C squared. And then we're going to add these together, 109 equals C squared. And then again, we do want to take the square root of both sides to find just C by itself. 109 is also not going to be a perfect square. So the side length of this hypotenuse is the square root of 109. Don't get too worried or freaked out about having a square root as an answer. That does happen a lot with right triangles. The square root of 109 is just a number. It is a decimal. If you can we can put it in our calculator and figure out what that decimal is. Let me see. Yeah, the square root of 109 equals 10.4403, and it goes on forever and ever and ever. But the square root is just a number. So keep that in mind. All right, and then for our last problem on the Pythagorean theorem, on this one, we are given one of the legs and the hypotenuse. So notice that this 90-degree angle, this length of the triangle, the side length of the triangle is the one that we don't know. So that means that this is either A or B. Again, you can assign whichever one you want to it. I'm going to go ahead and call this A, call this B, and our hypotenuse is always C. This is another area where students will run into some mistakes sometimes because I will see them do this. They'll do 3.9 squared plus 11 squared equals B squared. And the A and the B always have to be together, added together on one side of the equation, and the C squared has to be on the other side of the equation. Some students will take a shortcut with this and do some subtraction instead of putting it in this addition form. I don't want to get into that too much tonight. So this is the true way to set up this equation. So our A squared is 3.9 squared plus we're still keeping B squared here equals C squared. So we've got 11 squared over here on the other side of the equation. So then let's go ahead. I'm going to use my calculator to calculate 3.9 squared. That gives me 15.21 plus B squared equals, and then 11 squared is 121. And then we're going to subtract. Subtract 15.21 from both sides of the equation. And that gives us B squared equals, B squared equals 105.79, okay? And now, again, just like we did before with the C squared, we still need to find the square root because this is not the measurement of B. This is the area of this square that would be formed of B times B. So if we were trying to find the area of that square outside of the rectangle or outside of the triangle, that's what it would be, 105.79. But we want to find just that linear side length. So we need to do the square root of that. And let's see. Square root of 105.79 does not come out to be, I wasn't expecting it to come out to be an even number. But just in case it was. So B would equal the square root of 105.79, which is about 10.29. just rounding there to the nearest hundredth. But I'm going to leave it as square root of 105.79. Okay, so that is a quick overview of Pythagorean theorem. I have a ton of videos on Pythagorean theorem on my YouTube channel. If you'd like to check that out, please do so. My Tutoring Bee is my YouTube channel, and then you can just search for Pythagorean theorem. It's pretty easy to find. So I'll also try to put some links in the description of this. I'm not sure how to do that after the fact for Facebook and Instagram. Just got to bear with me figuring this out as we go. All right. Let's see. Let me check in over here real quick. Make sure everything is still running okay. All right, on the next page for our next pre-algebra skill, we're going to be talking about the triangle angle sum theorem. This one should be pretty quick. With the triangle angle sum theorem, sum meaning that is the answer when you add, right? So the sum is the solution to an addition problem. And with triangles, all three interior angles will add up to 180 degrees. So if we have a triangle and each of the angles are A, B, and C degrees, if we add up A plus B plus C, that will equal 180 degrees. So that's what we're going to do with these missing angles. So in these first two, they're pretty straightforward. We just have two of the angle measurements, and we're trying to find the third angle measurement. We're going to get into how to do that with some algebraic expressions down in the next problems. But let's go ahead and take a look at this. So one way that we can set this up is that we can do 115 plus 31 plus B equals 180. Pretty simple, simple as that. And now we're going to combine like terms. So 115 plus 31 gives us 146 plus B equals 180. Then we're just going to subtract 146 from both sides of the equation. And then B equals, let's see, this will give us 4 and 3, so 34. So this one would be 34 degrees. And we can always check our work on that. We could do 115 plus 31 plus 34, add all of that up, and that would give us 180. So 5 plus 1 plus 4 is 10. This is 6, 7, 8, and then the 100. So we do wind up with 180 degrees. Same thing over here. One of the ways that I've seen a lot of my students doing it when I'm working with them during tutoring sessions, the ways that their teachers have taught them to do it, is go ahead and just add up the two angles that you're given. So 29 plus 33, that gives us 62. And then we can take that 62 and subtract it from 180. As you can see, that's pretty much what we did over here. We added up the two angles that we were given, and then we subtracted from 180. So this is just, I guess, sort of a shortcut so that you're not writing out the entire equation. So then 10 minus 2 is 8, 7 minus 6 is 1, and then we've got 1. So angle B is 118 degrees on that one. All right. Let's go down to these two problems. So we're given some algebraic expressions. They're not just straightforward degrees on one of these angles on this first problem, but the equation is still the same. So let's go with 77 plus 50 plus 7x minus 3 equals 180. Now, I would recommend putting parentheses around this because this is the quantity of 7x minus 3 for this angle. However, because we're adding this amount, we don't need to worry about distributing anything. If we had a subtraction out here, we would want to distribute, but that's not really going to happen in this case when you're just adding up all of your angles. So I'm going to go ahead and just remove those to make it a little bit more simplified. All right, but we do want to go ahead and add up our like terms. So we've got 77 plus 50. So that gives us 127. These two is 127. And then minus 3 will give us 124. So we've got 124 plus 7x equals 180. And then we're going to subtract 124 from both sides. 7x equals 56. Then we divide by 7, so we get that x equals 8. So now this problem is just asking us to find the value of x. So we've done that. We found the value of x, that x equals 8. However, if the problem asks you to actually find the measurement of this angle, then you've got a couple of options actually. You would be able to figure out the measurement of this angle just using the 77 and the 50, and the 50 degrees, because of that angle sum theorem. But then you could also do 7 times 8 minus 3 to figure out the actual measurement of that angle as well. Okay, let's go on to number 14. Pretty much the same type of problem here. You might be able to see, let's actually show it a kind of a different way with what I was talking about before. So since this angle and this angle are 45 degrees, that's together, those two angles are 90 degrees. So out of our total 180 degrees that's in a triangle, if these two make up 90 degrees of that triangle, then that means there's only 90 degrees left of this triangle. So this third angle has to equal 90 degrees. So that's another way that we could set up our equation. We can skip the 45s. We know that this angle has to equal 90. So 4x plus 18 equals 90. So now we've got maybe a little bit more simplified equation to start with. We had to do a little bit of math to get to this place in the first place. So, but either way, let's go ahead and subtract 18 from both sides. And we get 4x. This is going to be 72. And so then x equals, let's see, 4 goes into 7 one time with 3 left over. That gives us 32. So that'd be 8. So 18. So then this one, we've got x equals 18. All right, let's see how we're doing. We're going to go on to our Algebra 1 next, squaring binomials and multiplying conjugates. Just checking out the chat over here, make sure we're okay. If you do have any questions, please feel free to let me know. All right, I think we're okay. Okay, cool. Let's go on to squaring binomials and multiplying conjugates. So let's talk about binomials first, squaring binomials. We see that in both problems 5 and 6 here. We see that this is a binomial. It's got two terms inside and it's being squared. So that's where we get that term from. So I'm going to go ahead and write this out. X minus 4 times x minus 4. I just like to write it out 2 times right beside each other so that we can do that distribution method that I was talking about last week. And then I'll show you kind of maybe a little bit of a shortcut on this next problem, because when we are squaring the binomials, there is sort of, somewhat of a pattern to it. So we're going to go ahead and take this x and distribute. And so x times x is x squared. And then we've got x times negative 4, which is negative 4x. And then we're going to distribute this negative 4. So negative 4 times x is negative 4x. And then negative 4 times negative 4 is positive 16. So let's just pause for a second and kind of notice the pattern here a little bit. These two middle terms are exactly the same. And that is going to happen every time when you are squaring binomials, because you're multiplying the same numbers times each other in both of these situations. So this came from multiplying x times negative 4. That's where this first one came from. And then let me just get a different color here. And then this one came from multiplying -4 times x. So we'll talk about that more in the next problem that we'll do, but this pattern does always happen. So then we just need to simplify this, and then -4x minus -4x, sorry, not minus -4x, just minus 4x will give us -8x, and then plus 16. And that is it. We have multiplied that binomial. We have squared that binomial. Now let's take a look at this one. I'm not going to write this one out 2 times side by side. We're going to follow the pattern that we noticed in the first problem. So we're always going to have the first term squared, so n squared. Then we're going to have the first term and the second term multiplied together, but then that's going to happen twice. We already know that. So we're going to get 3n and then another 3n. So we can just go ahead and double that. So we're going to have 6n. And then the last term is going to be squared. So 3 times 3 is 9. So we just can kind of save ourselves a little bit of time, a little bit of space on the paper by doing that little bit of a shortcut. Okay, on to the conjugates. So conjugates just mean that they are the same terms inside the sets of binomials. However, one of them is being added and one of them is being subtracted. We can see that same thing happening over here. We've got the 3x, 7 and 7, but then one is being added, one is being subtracted. So let's find out what happens when we do that distributive property on this. So we're going to multiply x times x, which is x squared. And then we're going to multiply x times positive 5, which is positive 5x. And then we're going to distribute that -5. -5 times x gives us -5x. And then -5 times positive 5 gives us -25. So now let's see what happens to our two middle terms that are like terms. Try that again. One of them is positive and one of them is negative. So just like before, we're doing that same pattern of multiplying the first term times this last term in the other set of parentheses. And then here we're multiplying the same numbers, but just an opposite sign. So it makes sense that we're going to get the same numbers, but just with opposite signs here. And they're going to cancel each other out. Positive 5x minus 5x equals 0. So now all we're left with is x squared minus 25. So that's what's going to happen every time when you're multiplying conjugates. You're going to get the first term squared, the last term squared, and it's going to be the difference of those two squares. So we're going to be subtracting them because this last one is always going to be a negative times a positive, which results in a negative. So let's see what we get over here. And again, just sort of take that little bit of a shortcut and skip those two middle terms. So what do we get when we square 3x? 3x times 3x gives us 9x squared. And then we know that those middle terms are going to cancel out. This will give us a positive 21x. This will give us a negative 21x. That's going to cancel out. So then we can just skip to -7 times positive 7, which is -49. Now this is going to come in handy. The reason I bring this up is because on the next page, we're going to be factoring all of these. We're going to be just doing this same process, but in reverse. So let's go ahead and take a look at that. All right. Okay. I wanted to mention this before we get started in these problems. I did use this website for these first two problems here. And then the other ones, I believe, came from CUDA software. Yeah, and we just have the 4 problems on here for tonight. Okay, so let's talk about now we're doing the reverse of what we just talked about and learned how to do. Oops, let me move that over. When I'm working on this skill with students, it's sometimes hard to see at first, but as you practice this, you will start to notice those patterns. So let's take a look at at this first problem here. We've got a squared minus 16a plus 64. So I always encourage my students just to take a look at the problems and see if there's anything that you notice. What do you notice about these numbers? Do you see any patterns with these numbers? So what I notice is that a squared is a perfect square because it's a times a. 64 is also a square because it's 8 times 8. In addition to that, the middle term is 8 times 2, or 8 plus 8, or actually, sorry, since it's negative, it would be negative 8 minus 8. But it's a double. So to me, that helps me see that this is probably going to be a perfect square trinomial, meaning that when we factor it, it's going to look a lot like one of these problems that we multiplied when we were doing the squaring a binomial. So let's see how that works out. Let's go ahead and set up our two sets of parentheses for this first one. A squared we know is going to be a and a. So we've got those in each of our two sets of parentheses. 64 is 8 and 8, like we talked about already. And then 16 is 8 plus 8, but then negative 16 is negative 8 minus 8. But that still works, even though we have those two negatives, that still works for our positive 64 here at the end, because a negative 8 times negative 8 does give us a positive 64. So we do wind up with a squared binomial. When we factor this trinomial out, we get this squared binomial. And we could always check our work by multiplying this back out and seeing if we do get this trinomial that we started with. Okay, let's take a look at number 5. So again, let's just take a look at this and see what we notice. 2n squared minus 32n plus 128. I don't see any perfect squares except for just the n itself, the n squared. But 2 is not a perfect square. 128 is not a perfect square. However, all of these terms are divisible, evenly divisible by 2. So we can factor out a 2 out of here. So let's factor out, this is just factoring a greatest common factor, a GCF. So let's factor out a 2 out of each of these terms, which is something we'd want to do anyways, regardless of how we're factoring. We always want to check for that GCF first. So 2, n squared minus 32n divided by 2 is 16n plus, and then 128n divided by 2 is 64. Wow, doesn't this look familiar? So different variables, but the coefficients and the constants are the same. So we know already that this is going to factor out into n minus 8 squared. However, let's go ahead and factor it. We know that negative 8 plus negative 8 is going to give us negative 16, and then negative 8 times negative 8 is going to give us that positive 64. So then we wind up with 2 times n minus 8 squared. All right, on to our last problems. Okay, we're doing good on the live streams. All right, here we have k to the 4th minus 36. So again, just take a moment. What do we notice? K to the 4th is a perfect square. K to the 4th, we could split up into k squared and k squared. And 36 is also a perfect square. 36 we could split up into 6 and 6. So, and we see that they are being subtracted. So this to me is a difference of 2 squares. So we're going to go ahead. For this one, we do need 2 sets of parentheses because remember, they're not exactly the same for this one. In the previous problems, we knew that we were going to be factoring and our factors would be the exact same. These are going to be close, but not the exact same. So we're going to go ahead and split up that first term, k squared and k squared. We're going to split up that last term, 6 and 6, and then one's going to be plus and one's going to be minus. It does not matter which is which. So we can make this one plus and this one minus, or we can flip it and make this one minus and this one plus. Same thing. All right, let's go on to this last problem. N to the fourth minus 49. Again, both perfect squares. N to the fourth is n squared times n squared. And 49 is 7 times 7. And so then again, one's plus and one's minus. So that is how we factor, conjugates. Difference of two squares. That's what I meant. Difference of two squares into conjugates. There we go. And that's it. That's all that I have for us for tonight for the Algebra 1 section. Thanks so much for joining me. If you're watching this on a replay, then please leave me a comment. Let me know what you thought. I do have just a couple spots left open for online tutoring. If you're looking for a little bit more support in math, feel free to reach out. I'd love to see if I can help you. But until then, I'll see you next week. Thanks so much.